Hello, everyone, and Professor Ivan. This is the Fundamental of Machine Learning course, and today we would like to present our project regarding airline passengers satisfactions. Let's start with the team member first. So each of us will be assigned to the specific roles, and we have Natty Bandit, Social, Jimmy, and me, Victor. So we separate our roles based on the like research, data preparation, modeling, and application and deployment. The agenda for this presentation will be as follow: introduction and hypothesis, data preparation, modeling, and apply the data to the off sample data. For the introduction and hypothesis, the reason that we chose these data sets because we would like to improve the travel experience and also to help the airline industry and companies to manage the resource and also the cost effectively. Therefore, we come up with some problems that like what makes a passenger satisfied and what are the significant factors as well as the flight characteristics, which is meaning that maybe a different class, like for economy, business, or first class, and also the duration of the flights as well. And the our hypothesis will be cleanliness and comfort result in satisfaction. And for the service quality, it will contribute to the overall satisfaction as well as the flight characteristic will increase the satisfaction as well. Let's start with the data preparation. In our data set, we have about 130,000 records and with 24 features. However, the ID column is not considered as in our model because it doesn't generate any insightful. Therefore, we'll remove this ID column. And for the target variables, we use the satisfaction, which is the binary classification that namely the satisfied and neutral or dissatisfied. The data set is a combination of numerical and categorical data. Therefore, I would like to discuss more in the data ranking process. In this process, we mainly have the two parts. So first is about the cleaning, and the second is about the feature selections. Let's start with the cleaning first. So because we have to deal with the categorical variables, therefore we apply the dummy variable methods to deal with this. After that, we handle the noun values with the mean and remove the duplicates. Thereafter, we apply the scaling with the robust scaler. Once we get this clean data set, so we apply this data set to the feature selection process. And basically, we apply the 5 methods. And once we apply that, we will see which one give us the least feature number of features. And also we have to test the methods by using the logistic model as well. This come up with the final result that in the end we chose the select from model and random forest classifier method. As you can see here, the reason we choose because I would say method number 2 and method number 5 can give us the least number, which is 7 features. But in terms of the accuracy, the method number 5 can give us the best one. That's why we choose this one with the 7 features. Let's move to the modeling part. Let's start with the splitting the data. We have split the data into a train, validation, and test set with the test size of the 30%. Also, to handle with this data set, we apply the classification algorithms. And in this one, we employ 7 classification algorithms. And there's the result showing that the RBF SVM give us the highest accuracy. Therefore, we will improve the performance of this SVM by hyperparameter tuning. In the tuning process, we use a gamma and C to tune the SVM, and it gave us the best score at about 92%, while the test score is 91.7%. So the final hyperparameter we got from this process is that C is 5 and gamma is 0.95. Let's move to the evaluation process. We evaluate based on the confusion matrix, RC, accuracy, and classification report. And in general, the result give us a pretty satisfied and pretty good performance. And that means we think this is a good model and can apply to the next step and deploy our data to the new data set. Well, so we go to the out of sample prediction process, which will apply to the new data sets that they are not in the train data set. So the process the pipeline will be the same from data wrangling, modeling, and evaluation as well. So at the beginning for the data, we select 6,000 out of 130,000 records. And therefore, we apply the same method to random our datasets for this new dataset. After that, we apply the same cleaning process, namely dummy variable, and handle missing values and remove the duplicates. Next, we modeled this data sets by applying the pipeline methods that we'll be discussing in the code reviews. Finally, we will evaluate our data set with the same method that we apply and we use with the data set, the trained model. So this after we have done the process and also the modeling for the new data sets, the confusion metric, ROC, and classification report gave us the very good result. And as you can see for the confusion metrics, the true negative and true positive perform very good compared with the others. And also for the RC curve, the area under the curve, even though is reduced, is lower than the train model, but in overall the shape, the lines can go like more practical and looks acceptable. In terms of the classification report, the F score is maintained very high, consistent, as well as the precision and recall. So when we compare with the train model in the next step, so I can show you like how different and how good the model apply in the real world. So in conclusion, this model, the SVM with the RBF kernel can work well with our data set as well as the new data sets. That means we can conclude that this model is not overfitting and can help us predict correctly and with a high accuracy. Okay, so let's compare a bit about the results. So in general, the result is pretty much aligned the same way. So we have a lot of the numbers of the true positive and true negative for the confusion matrix. For the accuracy is slightly, yeah, different, but still good. For the ROC curve, as mentioned, the from the trend set is like quite steep, and the area is pretty high, close to one, while the new data sets just reach about 17.79. But still, yeah, this is a very good results. For the classification report, the F1 score, precision recall, they're like pretty consistent and still provide us the good performance. Okay, for the code's review, I would like to start with the runtime for this project. So here is about 11 seconds for this project, and hopefully you can get the similar number as mine as well. Okay, and here let's check out some the data, the records here. So as you can see, we have the categorical and numerical variables. And for this part, there are like a satisfaction rating from 0 to 5, and it's come up with a conclusion whether this satisfaction is neutral or dissatisfied, or it is satisfied. And when we look at the statistical description of this data, and we found that there are two columns that doesn't work properly, and the data looks something that we have to inspect further, which is the departure delay and arrival delay. Because when we look at the first quartile and the median, so it's still start with the 0. That's why we have to inspect that. By inspection, the data for these two columns, so we use the box plot, and it is found that most of the data, they're below 400, and it's quite like condensed together, while there are some extreme outliers, which is about like 600, 700. That's why we came up with this conclusion that we'll remove the outliers if it's above 500. And here, this is the data for these two columns after we remove the outliers. Next one, I would like to discuss and show the codes for the feature selection. Basically, we employ 5 methods, and most of the methods will give us like more than 10 features, but there are only method 2 and method 5, which is give us the least number of features, which is 7 features. Therefore, because they're given the same number, we have to test this one, test the methods by using the logistic model. The result come with the the accuracy for the method number 5, which is the select from model and random forest classifier, perform the best. That's why we chose these features for our model. Also, for the random forest classifier, we think that maybe we can dive a little bit deeper and to see some insightful information. Therefore, we use the features importance. So we use this code to generate this plot. And as you can see here, now we can give some explanation about the features that important to this random forest classifier. However, this is the process of the feature selection, and therefore we will apply the selected features to our model. And once we apply to our model, and as mentioned, so in the end, the best model for this data set is the SVM with RBF kernel, and with this parameter C is 5 and gamma is 0.95. However, we found that this FVM cannot help the business logic, business perspectives to explain and understand about the factors, about what's going on for this prediction and what should they do. Therefore, we still employ the decision tree to help us in explanation. So this is the extra one from based on the model. So we employed a decision tree with a max depth 3 level. So here is a very useful, and again, this one can help us to understand more about the modeling, about to make the explanation and to see which one the business side or the resource that the airlines companies they should invest and should focus more so that they can earn more satisfaction, resulting into making more profit and generating more profit as well as the competitive advantage. Okay, so this is our presentation for this project, and hopefully you enjoy and have a nice day. Thank you.